Namaste, and welcome back to JEE Physics with Typical Monk. This is class 29, Logic Gates. Every computer, every phone, every chip speaks a language of just two words, 0 and 1, low and high. Logic gates are the grammar of that language. Tiny circuits that take binary inputs and return a single binary output. From three simple gates, OR, AND NOT, any digital circuit ever built can be assembled. And, remarkably, a single universal gate can do it all alone. Read a truth table and you know a gate completely. Today, the basic gates, the universal ones, and the exclusive, or one idea at a time. Here is what you will master today. First, binary and the basic gates. Second, OR, AND NOT, their symbols and truth tables. Third, NAND and NOR, the universal gates. Fourth, XOR and XNOR. And fifth, Boolean expressions and combinations. One idea at a time. Let us set the foundation. Digital logic. Everything is 0 or 1, low or high, off or on. A gate. A circuit that takes one or more binary inputs and gives a single binary output. The truth table. It lists the output for every possible combination of the inputs. Master line. From just three basic gates, any logic circuit at all can be built. Now, look at the picture. The three basic gates. The OR gate. Its output is 1 if any input is 1. The output equals A or B. The AND gate. Its output is 1 only if all the inputs are 1. The output equals A and B. The NOT gate. It inverts a single input. The output equals not A. The symbols. The OR gate is curved, the AND gate is D-shaped, and the NOT gate is a triangle with a small bubble. Now the truth tables, which define each gate completely. OR, 0 or 0 is 0. Every other case is 1. It is false only when both inputs are 0. And 1 and 1 is 1. Every other case is 0. It is true only when both inputs are 1. Not 0 becomes 1 and 1 becomes 0. A simple inverter. Read them. The truth table is the complete definition of a gate. Now the two gates that can do everything. NAND. It is and followed by NOT. The output is 0 only when both inputs are 1. NOR. It is or followed by NOT. The output is 1 only when both inputs are 0. Universal. Any gate, OR, AND, or NOT, can be made from NAND alone, or from NOR alone. Why it matters? Chips can be mass-produced from a single type of gate. The bubble. A small circle on a gate symbol always means inversion. Now look at the picture, NAND and NOR with their truth tables. NAND, it is the AND symbol with a bubble. The output is 0 only when both inputs are 1. NOR. It is the OR symbol with a bubble. The output is 1 only when both inputs are 0. Universal. Each of them on its own can build every other gate. A NOT from NAND. Tie the two inputs of a NAND together and it behaves exactly like a NOT. Now two more gates worth knowing. XOR. The exclusive or the output is 1 when the two inputs differ. XNOR. The opposite. The output is 1 when the two inputs are the same. XOR in use. It adds 2 bits. It gives the sum in a half adder. A symbol. XOR is an OR symbol with an extra curved line at the back. In Boolean, XOR equals not A and B, or A and not B. Now, the algebra behind the gates. Commutative and associative. The order and the grouping of and or do not change the result. De Morgan. Not of A and B equals not A or not B, and not of A or B equals not A and not B. Identity or 0 equals A and 1 equals A. Now match each description to its gate. Output 1 if any input is 1 goes to the OR gate. Output 1 only if all inputs are 1 goes to the AND gate. Output 0 only when both are 1 goes to the NAND gate. and output 1 when the inputs differ goes to the XOR gate. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. NAND and NOR are universal gates. Correct. Statement 2. AND gate outputs 1 if any input is 1. Wrong. Only if all the inputs are 1. Statement 3. A NOT gate has a single input. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the AND gate in statement 2. Now, the 2 mistakes that quietly cost marks. The truth, AND is 1 only when all inputs are 1, or is 1 if any input is 1. The trap, swapping the AND or truth tables. The second truth, NAND and NOR are universal, each can build any gate. The second trap, forgetting that the bubble means inversion, a NAND is not an AND. Now test yourself, answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. Output 1 if any input is 1, the OR gate. Question 2. Output 1 only if all inputs are 1, the AND gate. Question 3. The 2 universal gates, NAND and NOR. Question 4. Output 1 when the inputs differ, the XOR gate. And question 5. A bubble on a gate symbol means inversion, that is, not. Let us gather it all in one breath. Digital logic, 0 and 1, and a gate maps inputs to a single output. OR, AND NOT, the output is A or B, and B and not A. NAND and NOR are the universal gates. XOR outputs 1 when the inputs differ. De Morgan's laws link AND, OR, and NOT. Next plus, experimental physics, measurements, and error analysis. 2 symbols, every machine. The entire digital world is written in 2 symbols, 0 and 1, and spoken through a handful of gates. Or fires if any input is high, and only if all are, and not simply flips, and from those 3, every circuit follows. More astonishing still, 1 universal gate, NAND or NOR, can build them all. Learn each truth table, respect the bubble that means inversion, and remember De Morgan, and a whole branch of physics turns into clean, certain marks. Next class, the physics of measurement itself. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.